Hey everyone, so if you've ever thought that programming is all about memorizing complicated code, you're kind of missing the bigger picture. The real magic isn't about the language you're using, it's about the way you think. And today, we're going to break down exactly how to do that.
And this quote, it's really the heart of everything we're talking about today. You know that Hollywood stereotype of some coder just hammering away at a keyboard? Forget it. The real, smart work happens up here, in your head, way before your fingers even touch the keyboard. It's all about solving the puzzle. Come on, we've all been there, right? That sinking feeling when you've checked every comma, every bracket, and your code still breaks. It is so frustrating. But what if the issue isn't a typo? What if it's how you're approaching the problem in the first place? So that leads us right into the real problem with code. Let's dig into what's really going on, and more importantly, how you can get past it for good. Okay, this is a huge mindset shift you need to make. We tend to think computers are brilliant, but they're not. They're just perfectly obedient. They have no idea what you want them to do. They only do exactly what you tell them to do, step by step, like a recipe. And if one of your steps is wrong, the whole dish is ruined. Okay, so if the computer just follows a recipe, the solution is obvious, right? We have to perfect our recipe before we even start cooking. This next part is all about that, thinking before you type. And we're going to learn two super powerful tools to help you do just that. And our first tool for doing that is something called a logic flowchart. Just think of it like a blueprint for a house. You wouldn't just start building without a plan, would you? A flowchart is your plan. It's a simple visual map of every single step, every decision, and every possible outcome. It lets you see the whole journey before you write one line of code. Now, flowcharts look complicated, but they really only use a few basic shapes. You've got your ovals for the start and end points, you've got rectangles for any action or process, and the most important one, the diamond. That's for any decision point where your path can split based on a yes or a no. Okay, theory is great and all, but the best way to learn this stuff is to just do it. So let's take a really common problem and build a flowchart for it together. So let's walk through this together. We begin at the start oval. First step, we get a number. Simple enough. Now we hit our decision diamond. Is this number divisible by 2? Well, if the answer is yes, we follow that path down and print the word even. But if the answer is no, we go down the other path and print odd. See how both paths then lead to the final end oval? It's a complete map, no dead ends. All right, so you've got this awesome flowchart. Your logic looks perfect. But how do you know for sure that it works before you start coding? Well, that's where our second amazing tool comes into play, the dry run. And a dry run is, well, it's pretty much exactly what it sounds like. You get a piece of paper, a pencil, and you pretend to be the computer. You manually follow your flowchart step by step with some test numbers. It's the best way to catch flaws in your thinking before they become bugs in your code. All right, let's give this a shot. We're going to try to find the sum of the first 5 numbers. We all know the answer should be 15, right? 1 plus 2 plus 3 plus 4 plus 5. So let's do a dry run and see if our logic actually gets us there. So here's our table. We're going to keep track of our variables just like a computer would. Okay, loop number 1. Our counter I is 1. Our running total is 0. So 0 plus 1 gives us a new total of 1. Cool. Now for the second pass, I is now 2. We take our current total, 1, and add 2. New total is 3. Let's keep going. On the third pass, we add 3 to 3, we get 6. Then we add 4 to 6, we get 10. And for our final loop, I is 5. We take our current total of 10, add 5, and that gives us 15. Boom, it works. It matches what we expected. See? We just proved our logic was solid without writing a single line of code. Now we can go to the computer with total confidence. Okay, so we've got our two big tools, flowcharts and dry runs. Let's put them together into a super simple 4-step process, a blueprint you can use to solve any problem that comes your way. And here it is. This is the big takeaway. Step 1, really, truly understand the problem. Don't rush this. Step 2, map it all out visually with a flowchart. Step 3, test that flowchart with a dry run. And only then, after all that is done, do you finally sit down and write the code. This is how the pros do it. Okay, enough of me talking. The best way to really get this is to try it yourself. So it's your turn to put this blueprint into practice with a quick little exercise.
So here's a little challenge for you. Try to make a flowchart for a simple calculator that can add, subtract, multiply, and divide. After you've mapped it out, do a dry run with the numbers 6 and 3. Does your logic work? Go ahead, pause this, and give it a shot. Seriously, this is how you build that problem-solving muscle.
So if you remember one thing from all this, let it be this mantra right here. It's what separates the people who get frustrated from the people who solve problems. First, think, then code. That really is the secret. So I'll leave you with this question. You now have the exact blueprint that professional developers use every single day. The only thing left to ask is, what problem are you going to solve first?